Hey guys, my name is Peter Van Camp, and in this video I want to do a quick overview of my capstone project at RIT, where I developed a robotic welding work cell using a FANUC robot, Allen Bradley PLC, and Maple Systems HMI. Here's the fixture design for the cell. As you can see, there are two inductive proximity sensors that are designed into the fixture, and there's also two 24-volt DC electromagnets that are also in the fixture. The proximity sensors are used to let the PLC know when the tensile samples are placed in the fixture, and the electromagnets are used to lock the samples prior to welding. You'll also see a red laser line that is used to actually center the samples based on the weld teach points. So that actually marks where the weld points are taught from the robot. So every time we place the tensile samples in the cell, you will place them in the fixture, and then you can center it based on that laser line, lock the samples, and then continue with the welding process. Behind me, you can see the control panel that I designed for the work cell. It really created a clean way to house all the electrical components needed for the cell and have all of my field devices run into one central location. As you can see, I have it mounted directly on the robot controller, which really made an easy way just to run the Ethernet cable down to hook up between the robot and the PLC. Before I go into the HMI Graphics, I just want to give a quick tip, is that if you guys are having trouble sourcing an HMI stand that is budget friendly, an Amazon Podium actually worked out pretty well for me. It only cost me about $100, and if you really only need it for display or a super clean application, worked out really well. The only thing you got to be careful of is make sure there's not a metal post down the middle so that you can cut it right open, place your HMI in, maybe 3D print a few brackets because it is a little bit thicker than a typical HMI stand that's made out of metal. But anyway, it worked out pretty good for me, and let me know if you guys found the same application useful. Here are the HMI graphics I designed for the cell. This is the overview screen that you're looking at now, and as you can see, you can have a pretty quick glance of whether the tensile samples are in the fixture or not, and that gives the operator a pretty good window whether they can start welding or not. A few other things that are implemented in the overview screen are the ability to select your weld task. So here I programmed a normal straight weld along with a weave weld, and then also a tooling return in case any faults were placed in the robot. You can also select a speed override, which gives you an option when you're testing out programs. If you don't want it to run at 100%, you can obviously knock that down. The other cool feature is in my settings screen, I have a weld settings option where you can select the travel speed of the robot during the weld, and along with testing the wire feeder that's mounted on the robot as well by feeding the wire positive or negative direction. Also, I have an I/O status screen that I implemented in the cell mainly for troubleshooting purposes, where I can see all the PLC digital I/O along with my robot digital I/O. If I go back to my settings screen, I can also test my laser, which then if I go to I/O status, you can tell that my laser digital output is on. So that gives you a really nice way to test any of your digital outputs or inputs to make sure the cell is operating correctly. Alright, so this will be a quick live demo of watching the robot run based on the HMI input. So from here, I'm going to make sure my weld is not enabled so I do not blind myself. And I can select my weld program, so I'll start with a weave weld. Then I can cycle start, and it will weld in a weave pattern. From here, I can select a normal weld, which will just be a straight weld. And cycle start. And this will weld at 10 inches per minute. And then if there were to be a fault, and I abort the task, faults mid-cycle, I can reset the faults, I can abort my task, I can run a tooling return program, which then will slowly move back to its safe position where you can fix whatever is wrong with the welder. Alright, that's really it for the demo. Now, this project, I learned a ton in just the integration of FANUC and Allen Bradley together. So I've outlined all of the setup procedures to achieve really the same result as I did in my report. So I've dropped a link in the description for my website where you can download the report and all supporting materials as well, including like an IO mapping sheet, and the report outlines how to use all of that. So if you have any other questions, drop a comment or send me an email. Really anything, I would love to help you guys out.